Okay, so I'm going to introduce you guys to vectors. We're moving on to chapter 3 in our textbook. So first of all, this is just review. A scalar unit is a quantity that has magnitude only. So something such as distance and speed. Those are scalar units that you have learned already. Vector, on the other hand, vector is a quantity that has both magnitude and direction. So displacement, velocity, and acceleration. Okay, today we're going to learn how to draw vectors. You are going to need a protractor and a ruler. So make sure you have both before you continue the video. This protractor, you can see it's just paper. I printed it offline. I just typed in protractor. Okay, so let's go ahead and get started if you have those things, as well as a calculator that does trigonometric functions. So if you're looking at your calculator, you need the sine, cosine, and tangent functions for today. So drawing vectors. There's a few steps to drawing vectors. There's a few different things that you need to know. First of all, there's going to be an arrow. The arrow is going to have an angle and the length. Both of those things actually matter. So the angle is going to tell us the direction of the vector, and the length is going to tell us the magnitude. For the angle, we most often use cardinal directions. Cardinal directions are what you see on a compass. Okay, so let's do our first example. We'll start off with easy ones. So if I want to draw a vector that is 5 meters per second east. So I'm going to take my ruler, I'm going to use the centimeter side, and I'm going to draw it 5 because that is the magnitude. So 5 meters per second. And it's pointed to the right because that is the east direction. So if you don't know your cardinal directions, here they are. North, east, south, and west. Okay, moving on to another example. 10 meters per second north. So 10 centimeters. That's how long it's going to be, and it's going to be pointed in the north direction. There we go. 10 meters per second. Okay. So now let's go ahead and try one with an angle. 5 meters per second at 30 degrees north of east. So we want to be north of east, so 30 degrees. Once again, it's still 5 centimeters. So we know that if we draw a little compass, just a simple one with dotted lines, north, east, south, west. So I'm going north of the easterly direction. So north of east is going to be just like this, and 5 centimeters is from my 1 to my 6. We will notice that I should have used my compass. Looks like it's a little bit less than 30 degrees, so I'll try again. So here's my center. This is my line underneath. I want these lines to match up. That looks pretty good. Then I'm going to go, okay, here's 1, here's 0, here's 10, here's 20, here's 30. So it should be aimed with this little dot from this center, and it's 5 centimeters long. There we go. You can see why it's important to use a protractor. Right here I was estimating, right here is an actual 30-degree angle. So I will label that 30 degrees, and it was 5 meters per second. So disregard this one, please. Okay, the biggest thing here is that we went north of east. So we started out in the east direction and then we went north. So north of east. Okay, let's go ahead and do our first example where we are adding vectors. Adding vectors. Okay, example. A woman walks 8 meters west and then 5 meters north. We want to find A, her distance, and B, her displacement. So first thing she does is walk 8 meters west. So I'm going to draw a vector pointing to the left. So that's west. That is 8 centimeters long. This one's 8. And then I'm going to draw another vector 5 meters north. Okay. Displacement is always, remember, the distance. Let's just find distance first. That one's pretty simple. Distance is the total distance traveled. 8 plus 5, what does that give us? That gives us 13. So 13 meters is her distance. Her displacement, though, has direction. So it's start to finish. So we started right here. We finished right here. So that's where our arrow is going to point. And you could notice that we could kind of estimate, since we drew it to scale with a ruler, we could kind of estimate that it's going to be about 9.3 centimeters. So let's go, it's going to be about 9.3 centimeters. But I want to be able to be precise when we start doing these problems, and I want you guys to be as well. So we want to use our mathematics that we know. We're going to use the Pythagorean theorem. I'll just abbreviate Pythagorean theorem. If we don't remember it, it's a squared plus b squared equals c squared. Well, here's our 90-degree angle. So this is our A, this is our B, or vice versa, and this is our C value, the hypotenuse, our displacement. So let's go ahead and plug what we know in. We know A is 5, so 5 squared plus 8 squared is going to be equal to C squared. We want C, so we're going to take the square root of both sides. We get the square root of 25 plus 64 equals C. Go ahead and do that calculation. You should get C is equal to 9.43 centimeters. So that is our exact displacement. So that was our approximation. So let's put in our displacement. And then we want to know direction. So that's only the magnitude. So we want to find theta. Okay, so we're going to use what we've learned probably back in algebra, maybe algebra 2, SOHCAHTOA. So let's just have a little refresher on what is SOHCAHTOA. SOHCAHTOA, so we have sine. Sine of theta is equal to opposite over hypotenuse, or O over H. Cosine theta is equal to adjacent over hypotenuse, or A over H. And tan theta is equal to opposite over adjacent. More often than not, you're going to want to use the tangent function because that's typically what is given to us. If we look at our theta right here, opposite to this angle is 5 meters. Adjacent to this angle is 8 meters. So that's why we're going to use the tangent. So let's go ahead and do that. So tan theta is equal to opposite over adjacent. We get tan theta equals 5 over 8. And we want theta. So let's divide by tan on both sides. Well, dividing by tan is the same thing as writing it as tan inverse. So this tan cancels. We have theta equals, this is tan inverse now. So inverse tangent of 5 over 8. So on your calculator, if you have one of these, you're going to type in second and then the tan button, because you want the tan to the -1. 5 divided by 8, close parentheses, you get 32.0. You want to make sure that you are actually in degrees. So if you hit mode, you want to make sure you're out of radians and in degrees. In this class, the only time we use radians is when we're using pi. So make sure we're in degrees in this class. Okay? So you have 32 degrees, so our theta is equal to 32 degrees. Great, so now we know the angle. Let's see, let's make sure. Okay. 32 degrees. So this one, we're going to add at 32 degrees, and we have to figure out the direction now. So we're starting out going west, and then we're going north. So we're going north of west. So keep in mind that second north of west. This second direction is always where we're starting. We're starting in the westerly direction, and then we're moving north. So north of west. Okay, so that's part of our answer. Let's not forget that the direction. Let's do one more example. So instead, if I don't give you the x and y components, let's do an example in which I actually give you the hypotenuse this time. So finding x, y components. So our example is a woman walks 8 meters at 30 degrees east of north. A, how far east? So x component. And B, how far north? Y component. So let's first start off by drawing our vector. So we know it's going to be kind of up in this direction because east of north. So I'm just going to draw a little compass to kind of get me started. So I'm going to place it right on the right spot. Okay, we want to be 30 degrees. So east of north, so we're starting out going north and then we're going east of it. So actually we want to be this way. And then we're going to find, okay, 30 degrees this way is going to end somewhere about here. And I'm going to connect the two, and I want it to be 8 centimeters long. So here it was right here, so we don't forget. 8. There's 8. And our angle that we used was right here. This was our theta, equals 30 degrees. And our length of our vector is 8 meters. So there's a few things. We can add in an angle right here. This is a 60-degree angle, if we needed to. And we're going to have a y component and an x component. So our y component is going to be straight up right here. Sorry that it goes over top of my writing. Hopefully you space yours out a little bit better than I did. Y component and our x component is right here. So x, y. Now we're going to find our x and y component. So x, in order to find x, that's our green arrow here. We know that if we look at this, we know the hypotenuse, and our x is actually from our 30-degree angle. It's opposite of the 30-degree angle. So we're going to use opposite and a hypotenuse, which is sine. So sine theta is equal to opposite over hypotenuse. I always want to choose the trig function that has both of the things that I want in my problem. So I want x, and I already know 8. So I know I want the opposite, and I know the hypotenuse, and I know theta. So we can go ahead and fill this in. Sine of 30 degrees is equal to x over 8. Well, if we want to solve for x, let's just do a little bit of algebra. Multiply 8 on both sides. The ones on the right canceled. You get x equals 8 times sine 30. Plug that in your calculator. 8 times the sine of 30 gives me 4. So x equals 4 meters. You may already remember this because you know your 30, 60, 90 degree angle. That's fine, but I want you to know how to calculate it also. Okay, and for the y component, well, our y side is the adjacent side. So we want adjacent, and we know the hypotenuse, so we're going to be using cosine. So cosine of theta equals adjacent over hypotenuse. Cos 30 equals y over 8. Multiply 8 on both sides. You get y equals 8 times cos 30. So our y is 6.93 meters. So there's our x and our y components. Okay, that's simple. I want you guys to go ahead and watch another video on the complex problems. You're going to watch complex problem 1, 2, and 3.